So here's where the proofs get interesting. These are the best kind, proving triangles congruent. So copy this down in your notebooks, all the givens, pause, and when you're ready to go, hit play. Okay, so our goal is to prove that the two triangles are congruent. Triangle ADB is congruent to triangle CDB. That's what we're trying to prove. So let's go through our given information. For each piece of our given, we're going to make a conclusion, right? So if I know that DB is bisecting angle ADC, right? If you think about how you would mark that on your picture, marking that on our sketch, we would mark these two angles congruent, right? Well, then that would mean that that should be our next statement in our proof. That angle ADB is congruent to angle BDC, and that's your definition of angle bisector. Now the next piece of information that we know is that angle ABD is a right angle. And what some people, like, it's kind of like knee-jerk reaction. When you're told you have a right angle, you want to say it's 90 degrees. But remember that a right angle tells us more than just 90 degrees. Think about how a right angle is formed. A right angle is formed by perpendicular lines. If our goal is to try to get these two triangles congruent, we're going to have to try to find another angle that we know that could possibly be a right angle. So if this angle right here is a right angle, that would then tell us that these lines are perpendicular. And if these lines are perpendicular, we also have a right angle right there. And if we've got two right angles, those angles are congruent. So let's see how that looks in a proof. So, by the definition of perpendicular lines, we would say that segment DB is perpendicular to segment AC. We know it's a right angle, right? So if an angle is a right angle, then its sides are formed by perpendicular lines. And then if those lines are perpendicular, we then know that angle DBC is a right angle. Same reason, definition of perpendicular lines. And if we know we have two right angles, so ADB is a right angle and DBC is a right angle, then we now know that those angles are congruent by the right angle congruence theorem. Okay, it's a lot all at once. Okay, still keeping the end in mind, we need to prove that the triangles are congruent. Well, look at what we have kind of set up here already. We have angle and another angle. So, yeah, it's a right angle, so you could consider, okay, so what are our options, right? We have side, 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 angle, side, angle, side, angle, 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 side, and HL, right? So we've got 5 possibilities. Well, we could right now cross off side, side, side. Ooh, where's my pen? It's weird. Side, side, side could be crossed off because we don't know anything about 3 sides. We don't even know anything about 2 sides, so we could also cross off side, angle, side. Now, that leaves us with one of 3 possibilities. We can get angle, side, angle, 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 side, or HL. Now, think about what HL means. It is for a right triangle, and yes, we have a right triangle. But it means that we need to have the hypotenuse and a leg. Well, right now, I don't know anything about the hypotenuse, nor can I find it out. So hypotenuse leg is going to be chopped off the list. Now we're going to look at angle side angle or angle angle side. Can we find or do we have an included side or a non-included side? So think about your 2 possibilities. Is the side going to be included or not included? Well, if I look at my sketch here, it's going to be non-included. It's right here. I know this side is congruent to itself. That is what we call the reflexive property. So by the reflexive property, segment DB is congruent to segment DB. Now we just set ourselves up for angle, side, angle, angle, side, angle. And we're finished with the proof. We're at our proved statement. Triangle ADB is congruent to triangle CDB by angle, side, angle. So let's look at another example of a proof with congruent triangles. Copy this one down, pause, and when you're ready to go, hit play. All right, so we're told that F is the midpoint of segment EI, right? And as soon as you read a given, you should think about what that means to you in the proof. How would you mark it in the figure, right? Well, if I'm told that F is the midpoint of EI, then I know that segment EF is congruent to segment FI. That's what we should be writing as our next statement. Segment EF is congruent to segment FI by the definition of a midpoint. Now, a lot of times, these proofs could go many directions. So some of you might be looking to use vertical angles here, which would not be incorrect at all. You could definitely do that. But I'm trying to focus on my next piece of given information, which is that EG is parallel to segment HI. Now, if those segments are parallel lines give us angle relationships, right? So if I were to mark my figure that here's my parallels, I've got two big old Z's. You know how I am. I like to find the Z. So if I did a Z this way for alternate interior, boom, oh that's messy, sorry. This angle and this angle are congruent. And I could do another alternate interior using those same parallels. There, here, and here. Okay, so let me erase that, make that a little neater for you so you can kind of see what's going on. Okay, so I keep it nice and neat instead of tracing them out. I just showed you how to trace them out. So we know that these two segments are congruent. Through alternate interiors, being the lines are parallel, those two angles are congruent, and these two angles are congruent. So that's my next step in my proof. I'm going to use the alternate interior angle theorem to list those two pairs of congruent alternate interior angles. Again, somebody might do this a different way, but that is okay. We would just read through it. I'm just showing you this example. Okay, now, we've exhausted all of our given. It's time to focus in on that proof statement. The proof statement is that we need to get segment EG congruent to segment HI. Okay, so I'm going to put here, dot and dot. So I know where I'm focusing. I need to get those two segments congruent. Now, if you look at everything you have already, it looks like one of our shortcuts, doesn't it? It's angle, angle, side. Angle, angle, side, and here angle, angle, side. So I actually have the two triangles congruent by angle, angle, side. And if I have that the triangles are congruent, well then that would mean that all of the corresponding parts are congruent. Okay? That's something called CPCTC. I don't remember if we wrote this in our notebooks yet, but CPCTC, say that 10 times fast, stands for corresponding parts. All of a sudden my pen went on me. Parts of congruent triangles are congruent. So you want to write that down. CPCTC stands for corresponding parts of congruent triangles are congruent. So that means if I know that my two triangles are congruent by angle, angle, side, I know that any other part that's not already listed will also be congruent, meaning segment EG congruent to segment HI. So let's write it. So now I know my triangles are congruent by angle, angle, side, just like we said, right? And then, because the triangles are congruent, we only have 3 of the corresponding parts listed. We could list whatever other corresponding parts that we still need. And the only one that we're concerned with is segment EG and segment HI. Those are going to be congruent, and the reason is corresponding parts of congruent triangles are congruent. Very important to remember that. CPCTC. Corresponding parts of congruent triangles are congruent.